Hello everybody and welcome at LAUMAS webinar about the Inclinometer function onboard weighing. It is a pleasure having you here today. I am Luca Fanni and I've worked at LAUMAS for about 15 years and I work at the sales department. I will introduce you the first part of this presentation and the second part will be a practical demonstration made up by the engineer Grisanti Matteo. The webinar will last about 40 minutes plus 20 minutes about question time. The today webinar concerns the onboard weighing and we'll see the inclinometer function used on sloped surfaces conditions. Let's start to see what we are talking about. As we know, on standard weighing system, it is used a bubble to level the frame just to avoid errors on the weighing reading. When we weigh on a vehicle, the dynamic nature of the vehicle causes some precision and stability issues on the weight system performance, while the required weight stability could be obtained by the weight filtering implemented on the weighing instruments. There is another aspect to be carefully considered: the inclination applied to our weight receptor. For example, considering a delivering vehicle could stop during its service on a place characterized by a sloping street. Despite the inclination of the lorry, the weight displayed on the indicator must be precise. If a weight 1 tons, I have to read 1 tons on the indicator. The load cell mechanically linked to the inclined load receptor are able to measure the perpendicular component only. This means that calculated weight is a distorted value dependent by inclination values. So, in order to improve the performance of our system, considering this effect, we provide a specific compensation function. LAUMAS Elettronica has built a specific software which, installed on multi-channel LAUMAS transmitters, allows to control and manage the necessary parameters to obtain a correct weight when some errors due to the mechanical structure strained by the inclination of the means of transport. More specifically, the LAUMAS solution for onboard weighing is composed by, let's see, a multi-channel weight transmitter, an inclination sensor, in case we exploit a biaxial incline sensor, which in the application has to be mechanically connected to the weight receptor in order to measure its real inclination. A LAUMAS weight indicator, which allows to remotely display the weight sent by the multi-channel transmitter and which could be placed, for example, in the vehicle cab, where the driver could monitor the load or unload operation. The LAUMAS transmitter could be connected directly to your PLC or and HMI panel, or only your HMI panel, avoiding the LAUMAS indicator. And last but not least, the load cells connected to the weight receptor to measure the kilogram force, or anyway the force. The inclination compensation function is completely manageable by remote operator panel, HMI, by Modbus RTU, on a serial link or field basis if it's installed on the transmitter. Besides the serial port, many available field buses can be chosen among the ones on the market from the most important PLC brands, as you can see in the slide. Let's see the main features of the LAUMAS inclinometer weighing system. The maximum operating range is minus or plus 10 degrees. Once exceeded these values, the tilt message will appear. The software compensation mechanism is based on two-level approach. We implemented a second-level compensation in order to improve the measurement performance if required. We have configurable maximum allowed inclination value with a tilt function associated. This feature allows to communicate an excessive inclination condition may be source of an hazard due to mechanical limits of the vehicle. Two parameters, max x and max y, can be set to fix the maximum inclination on each axis. Once exceeded these values, error messages will appear. The LAUMAS solution allows to make a homologated weighing system for non-automatic weighing according to the OEM LR76 for using with third parties. The certified weighing system must be verified and sealed by a local company or metrology office before using it with third parties. The deadline of this verification depends on any single UE country. The load cells we are choosing for this kind of system must be homologated, as the inclinometer, transmitters, and indicators are. If an operator panel, HMI or anyway PLC, will be installed, which is not supplied by LAUMAS, it must be certified all the complete weighing system. The onboard weighing solution allows to improve the results compared to standard weighing. We could say we can weigh everywhere, every time, and get easy access to the weighing data. The means of transport can travel full, avoiding wrong order, which could not well consider the tank capacity of the specific means of transport. The customer or supplier will always have a direct and immediate feedback concerning the delivered or moved goods. So we will save time, work, and money. There is also the possibility to make a verified system which can be used with a third party. As I said before, the customer will be immediately notified of the amount to be paid for delivered good, and we can deal direct selling then. Okay. Here some of many possibilities in terms of final application where a weighing system could be used once installed on a vehicle. For example, let's say in case a distribution service would supply a large quantity of flour on a pallet, the weighing system enables the exact measurement of the quantity of product delivered to the customer directly during the delivery. Or we could wait, for example, milk to realize immediately how much milk we filled into the container, or how much we are delivering to the dairy processor. or another one could be once the weighing system is installed on a vehicle used in a garbage disposal system. In some kind of plant, the exact amount of garbage produced by citizens could be monitored and priced. We could also load our truck at the maximum limit, avoiding an overload. We can travel safe, and in the case of police weight control, we are in compliance with the law. We could weigh a container directly on a truck, and this solution could be useful to satisfy the SOLAS weighing, which means safety of life at sea, which is an international convention, and it rules how the container must be weighed before being stowed on the ship. The SOLAS convention says the shipper have to declare the gross weight of the container, but often who makes physically the weighing could be the producer or some other company who weigh in a different way compared to weighing the full container. Any UE country can decide whether the SOLAS weighing system must be homologated or not. In Italy, for example, it must be homologated. Further possibilities could be the pallet truck scale, where LAUMAS installs the inclinometer on the standard CEM approved version. The forklift column is another example where you can install the inclinometer. It is also possible installing it on some kind of forks that you can find also on the market. On these systems, it is used the limit switch function, which stops the weighing over a specific inclination of setting, and it doesn't make any adjustment or correction on the weight. In some cases, it could be useful installing the inclinometer on a platform which moves on wheels back and forth on each spot of its path. As we know, the platform has to work on level, and if not possible, we could use the LAUMAS system, which corrects the weight. We can see a panoramic view of components required for a weighing system with inclinometer. So we have load cells, just some examples, inclinometer sensors, multi-channel transmitters, and weight indicators. The HMI operator panel and/or PLC, which are not supplied by LAUMAS. Here we are with LAUMAS digital multi-channel transmitters. These electronics can be used in different modes, but today we'll see only the inclinometer one. The TLM8 multi-channel transmitter can be installed on DIN rail into back panel or in its boxes with or without external keypad, with or without cable glands, or end fitting for sheath. The TLB4 multi-channel transmitter can be installed on front panel, excluded a few versions, or DIN rail back panel. The CLM8 multi-channel transmitter is available in polycarbonate IBS boxes, both with or without cable glands, or end fittings for sheath, or available as only board. The transmitters have the lossless millivolt input and the RS485 or RS232 port to communicate with the inclinometer sensor and the indicator. After making the digital equalization, we can proceed with the theoretical calibration or real calibration with sample weights. Afterwards, The transmitter processes all the detected data from load cells and inclinometer, and it will communicate the correct weight to the indicator. The multi-channel transmitter allows to see the percentage of load on each load cells directly on its display. This is useful when we weigh a tank where the weight is not constantly and equally distributed on the load cells. It makes a diagnostic and displays errors. For example, there could be a problem with a specific load cell. By the full communication protocol supplied by LAUMAS, the operator panel can manage any transmitter's functions, which are not possible on LAUMAS indicators, which get only the weight. The transmitter continuously reads the current inclination value by the sensor, exploiting it properly, correct the weight calculated. An OEM software firmware could be evaluated in case you already work with your specific inclinometer. In this case, your sensor must have a serial port RS485 or RS222 to work with the LAUMAS multi-channel transmitter. LAUMAS has developed the Instrument Manager. This is a tool, a software tool, which is a free PC tool to manage the transmitters by serial port. Some of the most important features are exporting and importing the calibration and settings which have been created or duplicated. You can update the software of the transmitter. Reading the real-time weight and the real-time chart will help you to understand the weight trend and some parameters. As I said before, we have seen some example of load cell. We can choose among many different load cells according to specific installation, the supports, the capacity, the material, the protection, and the other features required to develop the project. Here we can see some types of load cells. There are load cells for multiple supports, bending beam, shear beam, compression, single point load cell for single support, mostly used individually and for medium low capacity. They are used to support a platform whose maximum dimension will be found on the load cell data sheet. To work properly, the load cells must be fixed with suitable mounting accessories which allow them to get and transmit the force, eliminating or limiting as much as possible dangerous forces to the load cells and avoid damages and wrong weighing. I would point out the load cell is not a security chain or tools, but it is only a sensor. Just for this reason, a security system must be provided in addition to the load cell. To be able to compensate the inclination errors, we need the help of the inclinometer sensor, which will be installed on the mechanical weight structure, and it will detect the onboard weighing position, sending the information to the transmitter via serial port according to the one available on our transmitter. To project our software, we use the inclinometer sensor you can see in the picture, the NS15DPN2RXG, which is just the board, and the NS15DPG2RUG, which is the board inside its protection case. You can also find this sensor available on the market, not only from LAUMAS. As LAUMAS indicator, we could consider many models as WDesk, W200 box, WINOX, W200, WDOS, W100, WTAD. We will choose a specific indicator according to different kind of need, as plant, installation, power supply, display, IP protection, explosion protection, and other certifications. Indicators have standard RS-232 and RS-485 port, set points, tare zeroing, net gross weight, and other output, including analog outputs and feed buses of the most used PLC. LAUMAS indicators get and manage only the real-time weight from transmitters. The display of the homologated indicator must be always visible by the operator. So, for a sealed plant with used by third parties, the indicator must be visible by the operator. The alibi memory must be installed if the weight is used by an external processor not homologated, so that the weight can be recorded and traced by a progressive number on the homologated device. LAUMAS indicator is not mandatory. It actually doesn't manage complex operation as a PLC or Edge MI, as I told you before. By the Edge MI operator panel and or PLC, it is possible managing all the transmitter settings and functions by the LAUMAS full protocol. The Edge MI operator panel is often used on these plants just to be able to manage different and complex operation by your own software, not only concerned to the weight, but also issuing, for example, delivery notes or invoices, detailed printing, recording on your database, satellite signal, position of the goods, and many others. So you can personalize it. The Edge MI and PLC are the only devices not supplied by LAUMAS. A LAUMAS indicator is already homologated to be used with the Inclinometer weighing system on sealed plant for using with third party. But the Edge MI and or PLC must be homologated by the producer together with the other LAUMAS components. So you have to seal, homologate and seal all the complete weighing system or machine, or all the complete machine. Okay, this is the last slide, and on this diagram I will put you through the engineer Matteo Grisanti, who will proceed with the practical demonstration.
Okay, thank you, Luca. Good morning. I'm Matteo Grisanti. So we can start with this scheme that reports substantially the elements composing the setup we will use during our demonstration. Also in front of me we have all the elements needed for the demonstration. So here we have a little scale with a single offset load cell. On the frame of this scale, we previously installed one of the two inclinometers we make available to exploit our inclinometer management function. And both load cell signal and inclinometer readings are retrieved by the core of our system, the CL8 multi-channel transmitter, with the connection between the CL8 and the inclinometer realized by an RS-232 link. At the same time, in order to manage this demo system, we will use a couple of different instruments. Namely, we will use our last service tool, Instrument Manager, and in the last section of our demo, we will use a commercial tool, Modbus Poll, in order to establish a connection to the CLMate and exchange of data using a TCP/IP connection. So we can start by Instrument Manager. We can put a sample weight on our scale. Instrument Manager is a software that, as told by Luca, allows to connect to LAUMAS instruments using serial connections. In this case, we are exploiting the RS-485 interface of our CLMate. And once the instrument is found by the software, we can connect to it. Now the software are retrieving all the configuration data directly by the instrument, and all the retrieved information are displayed in the software interface, already subdivided in different tables. So, for example, in the first table here, we see all the data related to the calibration of our system. So we are able to see the theoretical full-scale value, in this case 50 kilograms, and the division set, in this case 2 grams. If we would like to try the inclinometer management function, we have firstly to set this function. To do this, we have to access to the serial interfaces parameters, and in this case for the RS-232, select as a protocol value the inclinometer option. After this change in configuration, we have to synchronize the configuration we edited on the software interface with the instrument configuration. So we now upload the changed configuration into the instrument. Very well. Now we can reconnect to the instrument in order to work online. We have to wait only a few seconds because after the upload, the instrument has to be rebooted. So we can try to search again. Okay. Now we can connect to the instrument. Okay. In the inclinometer, once the inclinometer protocol is set on the interface, a new tab is available, displaying all the parameters that can be set in order to customize the working of this function. More precisely, we can define if enabling or disabling the compensation of the inclination of our weight receptor, and we can set the limits on both x and y axes allowed for our application, and at last we can act on the level of a specific filter function applied to the values retrieved by the inclinometer in order to suppress oscillations and noise related to different sources. Once online, we can access to now a specific window we developed in the last weeks in a new version of Instrument Manager. This window is not available in the Instrument Manager version now downloadable by our website. Let's say that it is an alpha version, what we are showing to you now. but we thought it could be useful because it gives a very good idea of what can be done with the remote management of our function. In fact, all the functions implemented in this window are based on a simple Modbus communication established now between the software and the instrument. The same kind of communication can be fully realized and implemented on exploiting any field bus interface that is available on our multi-channel transmitters. Okay, here we can see both the current weight and the current angles values. Currently, we have not enabled the inclinometer function, so we can try to substantially modify the inclination applied to our scale, and we can see the effect on the calculated weight of the distortion previously mentioned by Luca during his presentation. Okay. Now, starting from this position, we can enable the function of inclinometer management. Once the enable is set, first level, let's say a first degree of compensation is applied to the weight, exploiting simple physical formula. Maybe can remove the second level. Okay, and as you can see, our sample weight is 5 kilograms. Already applying the function to the weight, the value is corrected in a very good way. Now we can change the inclination. As you can see, the current angles are updated, continuously updated, because continuously exchange as information between the PC and the instrument, and the weight value continues to be quite precise. Actually, during our development, we noticed that in some particular condition, or in case of complex mechanical frames used as a weight receptor, some secondary effects could arise during the working, adding a further distortion to the weight value. In order to properly manage this distortion, we implemented, let's say, a second level compensation that can be enabled after a proper calibration procedure. This procedure requires substantially to store the condition and some parameters related to our weighing system once placed in a different inclination setup. More precisely, during the calibration, it's required, once the weight is stable, to register the condition of our systems once placed in a planar configuration, and then the user is free to define or put his system on an inclined configuration. In this case, we have a configuration involving an inclination on the positive axis of the on the positive axis. Once the weight is stable, okay, on a few seconds. Very well. The next step is active, so we can execute it. After the execution of these two steps, all the x-axis on the side of positive values is calibrating. So modifying the position again when the movement stops, makes the weight to be correctly corrected. The performances are quite good, also because now we are working with a 25,000 division. That is quite a high number of divisions. Okay. As told at the start of this short demonstration, the same kind of communication can be realized also exploiting one of the available communication interfaces made available by our multi-channel transmitters. Now we can switch to the Modbus poll tool. We already set a specific workspace. The CLMate we are using on our demonstration system is equipped with a TCP/IP interface. So we can start the connection, giving the right IP address previously assigned to our instrument. The communication is correct. In this weight and status window, we see the values of status register and gross and weight, net weight values retrieved by the instrument. Now, as an example, we can simply try to disable the compensation applied by our inclinometer. To do this, we have to write the zero value to the exchange register, and we can send a specific command in the command register of the instrument. As you can see, the weight value is changed because the inclinometer function has been disabled by this command sent by remote. In the same manner, we can re-enable it, this time writing the value 1 to the exchange register, and again sending the 302 command. The function is already working. So this is simply to show to you that all the functionalities related to the inclinometer can be properly managed by remote, and in a new firmware version that is in let's say test, is facing the test activities. All will be available to properly manage all the parameters composing the configuration of a multi-channel transmitter directly by each available field bus interface. With this last test, this demonstration is concluded. Thank you for the attention.
Okay. So now I will see if you posted some questions. Okay, so one question is, what happens if the accuracy when you exceed the specified angles? Will it give an error or still show the load?
No, I can show you briefly. The inclinometer function has a bunch of diagnostics implemented, and okay. Now we can connect again to our cellmate in order to show you that if the weight receptor goes in a configuration corresponding to an inclination that it's over the limits we set. For example, in our set we now defined we can modify the limits to 8 degrees, for example. We can upload them to the instrument. Okay. Now we can reconnect to the instrument. Only a few seconds. Okay. Very well. Okay. So now we are an inclination corresponding to 5 degrees. If we go to exceed the 8 degrees, we receive a specific inclinometer status register signals this condition. Obviously, in case of the instrument display, a specific error message will be displayed, so the weight is no more available on the instrument display. If in the application realized an HMI or a software is used to display the performances and the values calculated by the weighing system, this information retrieved also in this window have to be properly used to signal the condition to the final user, to the application user, let's say.
Okay. Another one, by my HMI panel, can I customize any functions? Is that right?
Yes, it's right. Okay, this window, for example, is built on the parameters that can be properly managed by remote. So also by an HMI, specifically related to the inclinometer. As I told, a specific firmware version will be released in the next month that will allow to properly manage by remote all the parameters related to the instrument configuration. We named this version as an extended protocol. Using this extended protocol, any HMI will be able to completely manage the instrument.
Okay. Another one. Do you know how it works, SOLAS in UK? Maybe I can answer because
yes,
I've heard that in UK the homologation, as I told you on my presentation, should not be required on SOLAS weighing systems. So you should verify if what I'm telling you is true, but that's what I know. Okay, there are no more questions. That's all. I thank you for your participation. Stay safe, stay strong, and we'll see you soon at the next webinar. Bye. Bye.
Bye. Thank you.